Okay, got it. Well, the time is ripe, just a couple of minutes past 6, and I'd like to greet everybody, especially our President, Professor Mainzer, and Violeta. Maybe you should invite our President to do something.
Thank you so much. We are very happy and honored because our president, Professor Klaus Mainzer, accompanied always when he can, he accompanies us. And this is so important for our colloquium. Please, I would like to give you the floor for the beginning.
Thank you so much. Yes, it is in the meantime a tradition. Dear members of the European Academy of Sciences and Arts, welcome again to our lecture series, Arts Meets Medicine, and thank you again to the both organizers, Violeta, Dinescu, and Dušan Šuput. This evening lecture is about mechanisms of memory formation and retrieval. And episodic memory, and I am especially interested in that by reasons of AI and cognitive science. Episodic memory is part of long-term explicit memory and compromises a person's unique recollection of experience, events, and situations. Episodic memories usually include details of an event, the context in which the event took place, and emotions associated with the event. It involves conscious thought and is, in that sense, also declarative. Your memories of your first laugh, for example, your first date, the death of a beloved person, or a personal event at school or university are all examples of episodic memories. For artists, such as composers, painters, or writers, episodic events are a source of their creativity. For example, The Rage over the Lost Penny, Opus 129, is a popular title of a piano piece by Ludwig van Beethoven, in which he processes an event in episodic memory. Beethoven recalls the event with vividness and temperament. He composed it, and that is also the title, Quasi un capriccio. That means like a capriccio. What is remarkable is the moodiness and originality with which the motives are combined, modified, and surprisingly transposed into unexpected keys. In the following lecture, episodic memory will be discussed using the example of Marcel Proust's great novel about à la recherche du temps perdu. Episodic memory is important as it helps individuals construct a sense of self. While episodic memory involves a person's autobiographical experiences and associated events, semantic memory involves facts, ideas, and concepts acquired over time. Besides psychology and art, however, the lecture is also about brain research, when the neuronal basis of the brain for episodic memory is examined. In the age of artificial intelligence, and that is one of my main fields, it has long been realized that humanoid robots can have a semantic memory that can even be more extensive than a human memory. My question is, will robots one day also have an episodic memory with all the personal and intimate feelings? So it will be exciting again tonight and I hope you will enjoy it. Thank you for your attention.
Thank you for introduction. Now it's my turn to introduce, and it's also a privilege to introduce Professor Hannah Monyer for this lecture today. And I must say that she originates from Romania. She spent her early education in Romania, but in 1975, she went to Heidelberg, and then she studied medicine. I must say that in 83, she received a license to practice medicine, and only in 10 years or 11 years, she became the professor at the Center of Molecular Biology in Heidelberg. She started as neuropediatrician, but then she was also a postdoctoral research fellow at Stanford University Medical Center, and also at the Center for Molecular Biology at the University in Heidelberg. So her education is quite broad in the field of, I should say, even biomedicine, not just medicine. After her professorship in 1999, she became a head of the Department of Clinical Neurobiology in Heidelberg. So it's a very rapid career, and I'm sure she deserves this rapid progress. She deserves this rapid progress completely, because her work is really quite famous. She also received many rewards in the field of medicine, but now I will focus on memory a bit, because her work is in researching the networks of neurons involved in memory, also is inhibitor interneurons with GABA. And once I already mentioned that the human mind works mostly in the way that we inhibit impulses, and in this way we focus in some direction. Maybe it's also important for retrieval of memory. She received many distinctions, many rewards, very prestigious rewards, but I must also mention that she was playing piano. And although I don't understand Romanian, I understand violoncello. And my idea is that maybe you play violoncello right now too, if I'm right. Okay, now we know why she appeared in the lecture that combines art and medicine. And we are looking forward for your lecture, and please present your lecture right now. Thank you.
Thank you. Thank you very, very much for this kind introduction. I was told, of course, that we have people from humanities. I will try to make it fairly simple, but the tenor of my talk is that we investigate in my lab, but also in other labs, we investigate processes that in cognitive psychology, but also in humanities, in philosophy, in art, have, been questioned for centuries. And what I particularly like is to look at different approaches, because empirical science can give us answers to particular questions. And these questions are very precise. They are very, and I like what I'm doing very much. Nevertheless, I try to bring this to a different level, and I try to embed it in the larger picture. So that is what I'm trying to do today as well, and give you a couple of examples how we analyze memory in the lab. I will give you, I will show you some of the techniques that we use, and why our memory, the episodic memory, you have Klaus Meinzer has explained it, and also so both the introductions actually gave already part of the talk that I wanted to give. It has been a wonderful introduction, and I will show you, or I hope to show you, that our memories do not register how things were really happening, but that I wanted to bring the message across that we transform our memories during daytime, during sleep, and upon every recollection. And then I want to give you an example how Marcel Proust actually 100 years ago, a century ago, actually got insight into this by sheer introspection and observation. And what we do now, we give the facts, we give the numbers, we give, what empirical science does, but others have, other approaches that also, are very, very important for us human beings. So now let me share my screen and let me see whether I can do this. Wait a second. Okay, so now I need to go into full view. I hope that very soon you will be able to see what I show you. Can you see it now, the first slide?
Yeah, we see. It's wonderful, yeah.
Okay, so I start with this goddess, Mnemosyne, who is the goddess of memory. And from this text of Hesiod, we already see the importance that was always given to memory in creativity, because here we read that Mnemosyne lay with Father Zeus and gave birth to the Muses, who soothe men's troubles and make them forget their sorrows. So Mnemosyne and creativity, as in the introduction, it was always said, are related. And of course, but they are very, very important for every individual as well. And of course, the losing one's memory, as it happens in certain diseases, such as Alzheimer's diseases, or having impaired memories, is very detrimental, not for the individual being, but also in social communications. And those who have seen a demented person know how tragic this is. Not only
Hannah, I would like to ask you, we see here the last pages, to 22, 23, 24.
Okay.
Yeah.
No, this is not what I want. So let me start from the beginning. Give me a second. And what about now?
Now we see you.
Give me a sec. I go share screen again.
Would you like me to make you?
No, because for whatever reason, okay, if I go back, what do you see now?
We see also all pages from 2 to 10.
Right, now I will go into the first.
You can go to the first page.
See. So do you see it now correct? Do you see Mnemosyne?
We see all the pages.
All the pages, yes.
I suppose you would like to begin with the first. First
but
page.
I see only the first one.
No, but we see all the.
Maybe you can just click on one and maybe it will show up.
But that's what I'm doing, I mean, that is exactly, I am on one, so I see only that one.
Yeah.
It is one very, very little, very short, because we see all the best, all of them.
Perhaps you must go to the slideshow.
I am in the slideshow. I just see the slideshow. I just see that. So that's why I also don't know where the trouble is.
Ce faci?
Măi, vezi că se aude. Unmute.
Mi-a scris Alexandru
Unmute.
că nu vrea nimeni să se întoarcă acasă.
Măi, unmute. Păi,
Că la toți le pare rău. Zice, scrie,
Măi,
nu se
Anut!
bucură nimeni că ne întoarcem. Și eu
Aoleu!
am crezut că zice că noi nu ne bucurăm. Zic, cum nu ne bucurăm? Abia așteptăm.
Give me just
Da, scuză-mă. Da, Violeta.
Apoi mi se aude tot ce vorbești. Am mute.
What about now? Violeta, what about now?
Now it's perfect. It's the first page.
It's the first page. Okay, let me see if I got
That
it.
is fine. That is fine now.
Okay, fine. So Mnemosyne, the goddess of memory. So I will go to the next one. Okay. But you see, my problem is now is that it does not move. I for whatever reason, this has, wait a second, I try it here. Okay, here we go. Fine. As I said, the interest in memory goes back to antiquity as far as we, I have text and we can read this. And Simonides of Chaos is thought to be the inventor of ars memoriae. What is the ars memoriae? This is a technique by which people have tried to improve their memory. So the significance to have a good memory was always recognized. The speakers in antiquity tried, to convey a good speech by learning it, things by memory. And they use the technique where they spatialize the memory. So things are put in a particular place, and I will give you an example of that. So in the next few slides, there is lots of evidence that you can memorize things better if you deposit the different things at locations that you know very well. And you will see in a few minutes why that is important, because space is indeed something that is very important for our memories. Most of our episodic memories are set in a particular location, they are set in space, and they are set in time. So people have used this to spatialize what they try to remember by putting these things. In this particular case, it is a complex text, and this text is being put, as this guy is doing, at the digits of his hand. And then when he goes back to recall the text, he sees the different segments of the text at the different segments of his fingers. So this we call music has been spatialized, as in this particular example. This is a very beautiful example from a text from 1500 that is in Karlsruhe. And this is a complex prayer where different parts of the prayer, again, are put on the different segments of the fingers. And then if you try to remember the text, you go back and see in your mental image the different segments of the text that have been placed in these locations. So the buzzword here is we associate a content with a specific location. We can memorize things better if we associate them with a particular place that is known to us. And over centuries, different places have been used. Here another example, and here another example. And one very beautiful example is Botticelli's depiction of the Inferno, where Dante, descends in the Inferno, and, he tries to use this technique of the ars memoriae to remember whom he has seen in the particular locations, so that when he comes back on Earth, that he can tell, details, vividly. Now, in neuroscience, ever since the discovery of Cajal and Golgi of the neurons and their visualization in particular, because of course they were discovered before, but they could not be visualized. But Golgi developed this technique of the silver impregnation technique that is still being used. And ever since, neuroscience has made great progress. And we now know that the neuron is the basic element that we need to memorize. And of course, there are particular structures involved more so than others. Again, a neuron has a soma, a neuron has an output, which is the axon, and the neuron has dendrites where it receives input from other neurons. And on the dendrite, as shown here in this magnification, there are specialized structures which are called spines. And here the cell receives the most input. And here there are the most numerous synapses. The synapses are the sites of contacts between two neurons. And we will look at this a little in more detail soon. So the silver impregnation technique has allowed or led to a tremendous increase in our knowledge about how the brain functions. Now here you see different neurons in the cortex that stem from Ramonica Hall, and these are the principal cells. I call cells the cells of an orchestra because these are the cells that make the music. These are the cells that do the work. These are the cells in the visual cortex that are important. Somebody has his micro on. Could you just turn off the micro because I hear a sound? So the principal cells are those that in the visual cortex are important for forming visual perceptions, in the auditory cortex for acoustic perceptions. And my lab works on another structure, which is the hippocampus, that I will introduce to you very soon. Here on the right-hand side, Shan, Šuput, it's yours micro. Can you turn it off, please? Dušan, can you please turn the micro? Yeah, what can I do? So on the right-hand side, we have GABAergic cells, which I also work on. And these are the cells in the brain that I call the conductors of the orchestras. They make that the music of these other neurons appears at the same time. So we use different techniques to study both those cells that code for content, as well as those cells that temporally synchronize other neurons in neuronal ensembles so that these neuronal ensembles can do their job. Now, here you have, for instance, two filled cells by technique in the structure that I am interested in, the hippocampus. And what you see here would be a cell soma and the dendrites. Don't you hear it, Violeta?
Oh,
Violeta, do you hear me? Or not?
I have the feeling that the microphone is not so good for you, or I'm not sure if I am the only one who doesn't.
No, I can hear her very well.
Ah, okay.
So there is just one microphone and it is at maximum, so it should work. I don't know. I've not done anything else from the other time. So I can try to talk louder, but I do talk loudly already because my voice does carry. So, and now I'm getting a little bit, lagging behind. So here there are two filled cells, and the message that I want to bring across is here in yellow, you see the axon ramification of a single neuron. So this is the output of this neuron, and such a neuron would make about 20,000 synapses. Reason why also to build models, to build computer models, of neuronal networks is not trivial, because these neurons have very, very complex connectivity, and we and others have studied this, but we are far from getting the full picture of how the brain is really wired. Now, I want to bring across the following message. What we see here enlarged is a synapse. And if we learn something, if memory is being formed, these synapses are modified. These synapses are modified qualitatively. And I will show you what happens in a synapse where an axon of one neuron is contacting the dendrite of another neuron, and this cell receives a stimulus. So when this happens, an action potential travels down and it releases a neurotransmitter. And postsynaptically, we measure this by a current. Under normal conditions, only this one receptor opens, and that is the AMPA receptor, a particular glutamate receptor. That's not important. And we can measure a particular current. Now, when we learn what you do when you repeat a poem, when you repeat certain things, or you study a language and you repeat a word that you try to memorize, there are several action potentials that travel down this. And now you see that, and again, so 3 action potentials, the neurotransmitter is being released. And in this particular case, the other receptors are also activated. And we know that it is this particular receptor, the NMDA receptor, which is the mnemosyne receptor in many, many, many brain structures in many cells. This receptor gets activated only upon repetitive stimulation, and then calcium goes into the cell. And now, days later, if a stimulus travels down the axon, you will see this now, again, this current will be much larger than it has been before. So this is what happens during learning. The communication between synapses becomes more efficient. And this becomes more efficient because more receptors are being put into the synapse. So the cell, it's not just these 3 receptors, but there are hundreds of these receptors, thousands of these receptors in a synapse. And the cell puts in more receptors so that when now an action potential travels down the axon, you get this enlarged response. So this is what happens during learning. Sometimes when the stimulus is very strong, you can also build new spines. So the message that I try to convey is during learning, something is changed in your brain. There are more channels that are being put in, synapses, and sometimes even new synapses are being formed. So please remember this. So our brain changes during, and we call that brain plasticity. And the good message is that our brain changes throughout lifetime. We can learn new things. The bad message is that such changes take place more easily in the young brain. So the older we get, the more difficult it is to learn something new because these processes are slowed down and eventually, they are barely noticeable anymore. So that is the bad, and I'm sure all of us, if you try to learn a new piece of music, if you try to memorize a poem, if you try to learn a new language, you will see that at the age of 50, at the age of 60 already it is, but this happens already much, much earlier, already at 20. So one actually says that the plasticity is maximum in adolescence, and it actually goes down already after the age of 18 or 20. So now we come, where does episodic memory first take place? And that is in the hippocampus. And the hippocampus is a structure here in the human brain that is bilaterally in the cortex. And we know from studies of the 50s of the last century that we need the hippocampus to learn something new. There was a very famous patient at the time, that was the patient HM, who suffered from epilepsy because his hippocampus had gotten damaged during an accident. And his hippocampi were removed in the brain. And this patient could not learn anything new. He was only 20 and something, and he could not learn new content, but he had access to his old memories. So these experiments were repeated in rodents, in monkeys, and so forth. And we know that you need hippocampus to learn something new, but this is then not kept in hippocampus forever. But during sleep and during periods of rest, this content is being transferred into the cortex. That is why this patient actually, he had access to old memories of his life, but he could not learn anything new. So when a nurse or a doctor entered the room and saw him and talked to him, the moment they exited the room and came back 10 minutes later, he would not remember that this event had taken place. Now, how do we study this in rodents? We implant electrodes. With these electrodes, we can measure the activity of individual neurons. We have different approaches to do this. And I will now show you how this looks in a lab. Actually, I will go to, in this particular case, you will see a mouse running in an environment, and you will notice the activity. Every time you will see a red dot, the same neuron fires when the mouse is in that particular location. I will let the movie run. So this is an animated movie. It is just a sketch. So the mouse is in this particular environment. The mouse runs, and a particular neuron, this neuron is active here, 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 and it is active in multiple places when this animal is in this environment. And now this is 20 minutes of recording. And you will see at the end of the recording, after 20 minutes, that this individual cell has been active in a very particular fashion. And we call these cells a grid cell. We represent it like this. This is a heat map. So in this particular location, this particular neuron has been active. Now let me carry you. I think I move on. I did not want this again. I'm very sorry. Oh my God, what is this? Do you see me?
We do not see, it's only grid animation, but we do not see.
Yeah, it is a problem.
Now it is something. It is,
yeah, now I go to the next slide because I don't want to have. So what I had shown you was this particular cell. So in the hippocampus, which is the gray structure, we have place cells, and O'Keefe got a Nobel Prize for discovering these cells. So you see here in a particular environment in gray, you see the trajectory that this particular mouse had run. And in red, every individual dot is the activity of this one cell. So this cell in the hippocampus, you have cells which fire just in one location. It tells the animal where it is. So this is one place cell. Underneath, there is another place cell. Here, this cell fires only when the animal is in the corner, and this cell fires only in this location. Now, in the structure behind the hippocampus, we have these so-called grid cells. That is the cell that I showed you in the movie. So one individual cell fires in multiple locations, but these locations are arranged in a grid-like, in a very precise grid-like fashion. And these cells allow the animal to compute the distance that it has run. Then we have in the brain the border cells. These cells are active when the animal reaches the border. And then we have speed cells that fire faster and faster, the faster the animal runs. And then we have so-called head direction cells. They fire only when the head of the animal is pointed to a particular direction in the room. So in the hippocampus and in the entorhinal cortex in the back, we have cells that code for space. We have cells that code, they are like a GPS. They tell the animal where, they tell the animal direction, they tell the animal the distance that it had run. So we are equipped in this structure with cells that code the rooms, the spaces in which we are. Now, it is important to know that from the 5 senses that we and the animals have, so smell, touch, vision, that all these cells project directly, they project to the hippocampus, and that's why our episodic memory are associated with spaces. Now, I will show you that the picture is even more complex. So I have shown you just before that in the hippocampus, we have place cells. But then, and I have shown you that in the entorhinal cortex, we have all these different cells, the grid cells, the border cells, the head direction cells. And then in yet another structure next to it, we have cells that code for content. So let me show you this particular example. Here we put an object from this location to that location. And what this particular cell does, when the object is here, the cell fires only in this location. And when we move the object, the cell fires in the other location. So in the medial entorhinal cortex, we have cells that code for the rooms, for space. So they code for the context in which something takes place. And in the lateral entorhinal cortex, we have cells that code for objects, cells that code for odors. So these are cells that code for the content. So LEC content, MEC context. And these two structures project to the hippocampus that unifies content and context. And there we have the place cells. So we are equipped with brain structures that let us code, context and content, which are united in the hippocampus. Now, you would think that this coding is a direct coding what happens in the world. But what this complex slide, and I will need a couple of minutes to explain this to you, what it will show to you is that we do not code things as they really are, but how we weight them. Things that are more important for us, we code in a different way than things that are not so important. But first, let me show you what happens under normal conditions. So if the animal runs in this particular environment, this is what I tried to explain. The hippocampus, we have a cell that is a place cell, which would be this red cell. The animal continues to run, and this particular blue cell would fire. It runs, and this pink cell fires. It continues to run, and the green cell fires. And this is what we see when we record. So this is time. The animal explores. This is exploration 1. So each tick is the firing of the cell. So first, this particular cell fires, then the blue cell fires, then the pink cell fires, then the green cell fires. Now, if the animal rests or goes to sleep, these cells fire. The brain, that is something that takes place that we call replay. So the brain does not only rest in particular sleep phases, but during sleep, we have a repetition of those sequences that happened before. And that is exact, but the repetition takes place much faster than during wakefulness. So since this is compressed and takes place faster, these cells that fire one after another, during sleep, they fire almost at the same time. And this, because of the repetitive firing, what I had shown you before in the other animated movie, the synapses between these two cells are strengthened. And these two cells and their synapses contribute to memory and to what has happened in this particular location. I will skip the second part. It's not that important. So I repeat, during wakefulness, we have sequences of events that are being coded, and during sleep, these sequences are being repeated. They are being compressed, and they, most importantly, from the hippocampus, they are transferred into long-term memory into the cortex. So these memories, they do not stay in the hippocampus, but are being transferred into cortex. And now what is very important, if the animal, let's say, encounters in a particular location food, this episode is being replayed much more often than an episode where nothing has happened. So I want you to stay with this very important message that our brain does code in a particular sequence of events, but upon repetition, we do not repeat these events exactly as they were, but they are modified by our brain. They are modified by our brain during sleep, and there are many other processes during which, upon repetition, we change these memories. Every time we recall them, we change them in a different way, so that after a few years, these memories actually do not resemble very much to what happened before. And again, this also explains why two people who attend a particular event, this event means something different to each of us, and it will be coded differently and it will be memorized differently. And maybe during the discussion, we can emphasize this again. But when we investigate the world, when we explore the world, already our perception will not code everything that takes place in an environment, but only what is important to us. And then this is further transformed during sleep and during rest and later. Now, I want to introduce, there are many, many other processes. I cannot give you all the processes by which we transform our memories. But of course, there is yet another important issue, and that is forgetting. And it was Ebbinghaus, a German psychologist who during the end of the 19th century already tested on himself and created this curve of decay. Ebbinghaus thought that memories decay with time, and he realized that if you learn something new, that in about 4 or 5 weeks, your memories, although you have learned something by heart and you were efficient to reproduce it at time point 0, these memories decay, and after 4 or 5 weeks, you are at the level of 20% of what you've learned before. However, if you repeat this decay will also happen, but now the memories do not decay to this level, but stay at a higher level. And if you repeat it again, it will stay yet at another higher level. Now, what he also showed, again, doing experiments on himself, was that this memory, this curve of Ebbinghaus, if you go into Google, you find it immediately. What he also showed was that the decay depends on the content. So if you study syllables that do not mean meaningless syllables, this decay would be more pronounced. And if you study a prose text, this would be the decay. If you study a poem, because the rhymes do help you, the decay is slower. And eventually, when you learn principles like laws of physics and so forth, if you have learned them to perfection and you understood the principle, this decay is not noticeable. So, but otherwise, our memories are a complex result of what happened that is being transformed already during coding, but also during forgetting. And I have to tell you, here we are not talking about some pathological forgetting. The most simple creature, like a worm, like a fly, they forget, and these processes have been studied in the lab. And it is important also to forget. So you don't need to know where you parked your car yesterday. So you need to free space in your brain, and certain things, also some traumatic things, need to be forgotten. Otherwise, we would not be able to survive in this world. So forgetting is also a constructive process and a favorable process of our brain. And at the end of the day, what we remember is a product of learning, of alterations of our memories during learning, because our brain is plastic and our brain constructs, our brain fills in missing parts, but also of forgetting. And again, we do not have time that I show you all the processes, but our brain is not, or our memories are not a product of a reliable
Hannah, hörst du
The sound
uns?
is gone.
Yeah, so I try to call her again.
We cannot hear you.
Yeah, but is she also, the image is Hello, Hannah, ce s-a întâmplat? Că s-au ies și intră încă o dată, ies și intră. Cred că așa trebuie. Că aici s-a fixat imaginea. Eu zic să ieși și să intri. Încearcă. Nu-i nimic. Ești foarte bine, ai făcut perfect. Da, până acum ieși și intră din nou. Cred că asta e soluția. Hai să vedem. When it happens such things, it's necessary to go out and come again. I asked Hannah to, I don't see what happens now, and she has to come again. We have to have a little patience. We can communicate in this time, during this time. if you would like to say something until Hannah appears again. So anyway, it is a very important subject about our memory, and what it is important is to know we have to continue to learn.
We must remember what she told us so far.
Yeah,
so that we can continue.
Yeah, she would like to to tell us so much, because this is a subject of her life.
Yeah, she just came to the point of limbic system. I was looking for the development.
Yeah, she will come again. Anyway, this changing of memory, when I communicate with her a lot, and she is the one who informed me about the changing of the memory, and I know myself that it happens to us. It's very interesting as process, and sometimes in life can become very dramatic, the changing of the memory. This is also the motive. Sometimes we can live in incredible happy moments and also disastrous moments because of changing. So I shall try again to call her. Așa, ai reușit? Am înțeles. Da. Nu-i nimic, nu te grăbi, pentru că noi așteptăm. Ca să găsești, dacă ai vreo problemă, dacă nu găsești, poți să-ți trimit încă o dată, dar nu cred că ți-am trimis. Da. Așa. Imă-mi de rue, ok? Te așteptăm. Da. Now she begins to enter again. The technique is upon us. This is, I am always very excited about technique and happy when it functions.
No, but this is
not wonderful. Okay.
So let me see. Do you hear me?
Yeah, we hear and we see you also.
So let me see if I share the screen now.
Hannah, don't speak so fast. Speak a little slower.
But I'm already late for it.
Doesn't matter.
It says that the participant can't see my screen. I don't know. It's not okay. Violeta, am dificultăți, îmi pare rău. Nu găsesc.
Știi ceva? Pur și simplu vorbește numai, pentru că ne-ai arătat imagini extraordinare și poți acum să vorbești. Asta e părerea mea. Apari tu și vorbești.
So what I can do, but this is, it's not okay, because I had the text by Marcel Proust that I now have. So I finished the scientific part, and excuse me, what I wanted to do, I have just 4 pages where I want to read from Marcel Proust's text, but they are very complex. And if I don't share I can try, but I do not. In the Recherche, he describes a scene where the protagonist goes to soiree, and at this soiree, a piece of music is being played. And while the music is being played, he wonders how our memory can retain in memory. So he asks himself the question, how we memorize. And reading this text, Marcel Proust manages to show 4 moments that in memory research are very, very important. So when he hears it's a sonata, and it is the andante of the sonata that impresses him mostly. And in this text, it becomes obvious that he does not memorize this andante per se, but he memorizes only the leitmotif. Why does he memorize the leitmotif? Because this leitmotif evokes in him a certain emotion. So Marcel Proust understood. So Swann is not a connoisseur of music. He's actually a visual person. He's interested in visual arts. He's interested in paintings. He's a collector of paintings. But nevertheless, just by surprise, this piece of music touches him. It touches him, and he waits for, basically with anticipation, with emotions, you know, very, he waits for and hopes that the petite phrase, what he calls it, that it comes again. So Marcel Proust actually shows in this text that something that happens is memorized in a very serendipitous way. What Swann stays with at the end of this evening is just a leitmotif. He does not memorize another piece of music. He memorizes this particular leitmotif. And what Marcel Proust also very nicely describes is that it is the repetition of this leitmotif. And everyone who has listened to music, that is, of course, what is being repeated. That is what the brain memorizes best. So in this little text, Marcel Proust shows that already at the perception, things are perceived not in detail, but just in a fragmented way. It is this particular just by chance, and it is fragmented because it touches him emotionally. And then because it is being repeated several times, he actually keeps this piece of music in short-term memory. And when he goes home, he actually tries to remember it and tries to search for it. He calls friends, he calls other people, he calls on them and asks, and he tries to figure out who has written this particular piece of music. So that actually a year later, when he's at a soiree again, and this piece of music is being played, he remembers it. And it gives him the same satisfaction that it has given him before. Now, what happens a year later is that a particular is there, and he had fallen in love with this woman, and this piece of music becomes their little hymn. So in this passage, Proust shows how context-dependent associations are being formed. And it is not only the woman, but also that saloon of the Verdurins, and also the people who are there that Swann associates with this particular piece of music. So the reason for the preferred storage of this music is, first, it is just a simple liking, a taste, you know, we have a taste for something. But then actually, Proust describes nicely that it is because this piece of music evokes very strong emotions in Swann. He forgets he forgets the rest of his life. The music evokes in him something that by that time, Swann had become a very blasé person. He has become very not interested in the world. But what this piece of music does, it reinstates in him passion. It reinstates a curiosity. He searches afterwards for details. Who has composed the music? And he wants to hold the scores in his hand. So, and then it evokes, and that is a very interesting part, it evokes in him stimulating thoughts, because what happens, it evokes in him synesthetic feelings. So as I said, Proust is a visual, no, Swann is a visual person, and what his music does, it evokes images. And it is this idea that the protagonist follows his own thoughts, and the music evokes this cognitive interest in something else, this pleasurable interest to discover more about this piece of music that makes Swann feel young again. It makes him feel in an interesting world. So all this, the rethinking, the repetition of the stimulus, the evoking of cognitive thoughts, the evoking of emotions, all these are variables that nowadays we know exactly what they do with our memories. And Proust has text that is not longer than 10 pages, has described all these different processes by sheer introspection into himself. Now, I do not know if I managed to read this text to you, because I would have to go into so you cannot see it, but I can see the text. So Violeta, shall I try
we see the text.
You see the text now.
We see short-term memory.
Okay, and then so you see the whole text. Okay, so there it says, so all these processes, and what I found very interesting is being underlined. So we read, but the notes themselves have vanished before these sensations have developed sufficiently to escape submersion under those which the succeeding or even simultaneous notes have already begun to awaken in us. Did not our memory, like a laborer who toils at the laying down of a firm foundation beneath the tumult of the waves, by fashioning for us facsimiles of those fugitive phrases, enable us to compare and to contrast them with those that follow. But now something very interesting happens, because I interrupt the reading. If our brain were to make a facsimile, then our memories would be identical to what has happened. And now Proust goes on, and he understands actually that our memories are not identical to what happened. And so we read. And so scarcely had the exquisite sensation which Swann had experienced died away before his memory had furnished him with an immediate transcript. So you can see now the second time, Proust does not call this a facsimile, he calls it a transcript. A transcript is not something that is identical to what happened. It is sketchy, it is true, and provisional, which he had been able to glance at while the piece continued, so that when the same impression suddenly returned, it was no longer impossible to grasp. He could picture to himself its extent, its symmetrical arrangement. Can you see now? I mean, this is a cognitive process. He analyzes the music, right?
We see, yes.
It's notation, it's expressive value. He had before him something that was no longer pure music, but rather design, architecture, thought, and which allowed the actual music to be recalled. This time, so this is the second time that this music he hears, the leitmotif, this time he had distinguished quite clearly a phrase which emerged for a few moments above the waves of sound. It had at once suggested to him a world of inexpressible delights, of those of whose existence, before hearing it, he had never dreamed, into which he felt that nothing else could initiate him. And he had been filled with love for it, as with a new and strange desire. Then it vanished. He hoped with a passionate longing that he might find it again a third time. When he returned home, he felt the need of it. He was like a man into whose life a woman he has seen for a moment passing by has brought the image of a new beauty, which deepens his own sensibility, although he does not even know her name or whether he will ever see her again. So in this text, Marcel Proust has woven in a number of very important things. He first wonders, so Swann, these are his thoughts. He wonders how our brain does it. And Proust first calls this a facsimile, but then he says, no, this is a transcript. This is what our memory does. It makes a transcript of what happened. This is sketchy, yeah, it is provisional and so forth. But then he actually also describes these strong emotions that this music evokes in him and the thoughts that they evoke in Swann. And this is, that is all connected with memory. If we feel pleasure, then this pleasure can be pure emotional, but it can be also pleasure that derives from cognition. When we recognize something, this gives us pleasure because we understand the principle. In the case of Swann, he understands something about his music. He feels something about it, and that is what makes him, that gives him pleasure. It's like love, right? It's like love. So we will move on. And this is all important for keeping something in short-term memory. Now, in long-term memory, this is just a few pages later. Indeed, this passion for a phrase of music seemed for a time to open up before Swann the possibility of a sort of rejuvenation. Swann found in himself, in the memory of the phrase that he had heard, the presence of one of those invisible realities in which he had ceased to believe, and to which, as though the music had upon the moral barrenness from which he was suffering a sort of recreative influence. He was conscious once again of the desire and almost the strength to consecrate his life. But never having managed to find out whose work it was that he had heard played that evening, he had been unable to procure a copy and had finally forgotten the quest. And now we are a year later. But that night at Madame Verdurin's, scarcely had the young pianist begun to play, Swann sensed its approach. So this is now a year later after he had heard the sonata the first time, and recognized, secret, murmuring, detached, the airy and perfumed phrase that he had loved. And it was so peculiarly itself, it had so individual, so irreplaceable a charm that Swann felt as though he had met in a friend's drawing room a woman whom he had seen and admired in the street and had despaired of ever seeing again. Finally, the phrase receded, diligently guiding its successors through the ramifications of its fragrance, leaving on Swann's features the reflection of its smile. So also here a fragrance. But now at last he could ask the name of his fair unknown and was told that it was the Andante of Vinteuil's Sonata for Piano and Violin. So this is a year later when, his beloved is there. And I think this is then the last piece that I want to read to you, this context-dependent associations. He would enter the drawing room of the Verdurins, where a place was kept for him beside Odette. Odette is the name of this woman. The pianist would play to them for their two selves the little phrase by Vinteuil, which was, so to speak, the national anthem of their love. He would begin with the sustained tremolos of the violin part, which for several bars were heard alone, filling the whole foreground, until suddenly they seemed to draw aside, and as in those interiors by Peter de Hoogh. So you can see now he uses a visual image. He associates this with a painting by Peter de Hoogh, which are deepened by the narrow frame of a half-open door. I know exactly which painting he talks about. In the far distance, of a different color, velvety, with a radiance of some intervening light, the little phrase appeared, dancing, pastoral, interpolated, episodic, belonging to another world. A triple past, simple and immortal, scattering on every side the bounties of its grace with the same ineffable smile. But Swann thought that he could now discern in it some disenchantment. It seemed to be aware how vain, how hollow was the happiness to which it showed the way. But all this mattered little to him. He contemplated the little phrase as a pledge, a token of his love, which bound her, Odette, to him by a lasting tie. So this is now the new context. It is this music that is the hymn of their love, which binds Odette to him. So much so that he had abandoned the idea of getting some professional to play over to him the whole sonata, of which he still knew no more than this one passage. Why do you want the rest? She had asked him. Our little bit, that's all we need. And that is how our memories function. We extract of the world that what touches us, sometimes by chance, sometimes because it evokes strong emotions from the beginning, sometimes where we build a construct, where we build images, where we have already previous knowledge and we connected what is in our brain, and sometimes by connecting it then with new associations to which, that give meaning to our life, and that then is again processed in our brain in a different way. So with this, I come to an end, and I hope that I have shown you that in neuroscience, we understand that our memory make constructs of what happens around us, that these constructs depend very much on our personality, on our liking, on our personal previous knowledge, that these sketches are being continuously remodeled, and that, of course, we have ways to study different mechanisms by which our memories are being remodeled, but there are also other approaches like the one that I have shown you. And I do think that that those of you who know Marcel Proust, they know the very famous scene of the Madeleine. There it is a smell and a taste that brings back to the protagonist his whole childhood. But the episode that I have chosen it also for Violeta, the episode I have chosen here is an example how Swann, thinks about how music is being memorized, but there is nothing peculiar about music. That is how all our memories are memorized. They are sketchy, they are not complete, they are constructed, and each time we remember them again, they are being reconstructed again. So I stop here. I thank you for your attention. And of course, I'm very happy to answer questions. And I'm very, very sorry that, because of the technical limitations, that there were interruptions. But I hope that you got the gist of what I tried to convey. And that is based on my own research and on research in neuroscience in general and cognitive psychology, forgetting, for example. But of course, also going back to Marcel Proust, whom, I admire a lot because he was one of the greatest psychologists of his time, and the insights that he obtained were from pure introspection and into his own soul. Also, he had a very, very keen sense of observation, and he observed the people around him, their weaknesses, their strength. But I do think he was very, very honest to himself, and that's why he left this work that gives us access to his own interior as well. Thank you very much for your attention.
Thank you very much for your introspective into memory and retrieval of memory. Now the lecture is open for discussion, and I'll take the privilege to ask you in the beginning, the filtering. We cannot remember everything that is going on during the day.
Yes.
Even in a moment right now, we are filtering so many inputs. So do you think that the orbitofrontal or maybe the renal cortex is a kind of filter?
I would not call the orbitofrontal cortex a filter, but what the orbitofrontal cortex certainly does, it focuses our attention onto something. We know that the way we process anything that happens around us is a mixture between, we call that bottom up, so that is the sensory input that goes into our brain, what we see, what we hear, what we touch, what we smell, and we call that top down. That is what you refer to. So top down is my expectation that I have. So I cannot perceive everything. I cannot smell everything. I cannot, but it is my previous interest, what I have learned already, but also what the orbitofrontal cortex is, where do I focus my attention? And so what you say is absolutely right, but that's just one of the many top-down mechanisms by which we select already from the very first perception, by which we select already what enters our brain. And more than 100 years ago, the Gestalt psychologists have taught us that, right? I mean, we see what we know. We bind things together in a meaningful way. We construct our world. And that is this mixture. And it's not only all attention. It can be also the state of how awake I am, my tiredness. If I'm very, very tired, fewer stimuli will enter my brain, right? So there are lots of mechanisms by which, you know, I make a selection, and this selection is not always a conscious selection. The selections can be conscious. I can focus now on you and ignore everything else. But it's a mixture of conscious selection, but also non-conscious, in the sense that this conscious selections makes me find previous memories in my brain on what I know already about the world. Yeah. So yes, my answer to your question is yes, the orbitofrontal cortex plays a role, but it's one of the many top-down mechanisms by which, my brain or me selects what I follow.
Yeah, you also mentioned somehow implicitly the limbic system. Now I'd like to ask you something which puzzles me, a kind of accidental memory. Sometimes you remember something that is completely irrelevant.
Right.
You don't know why you should focus. It should not be repeated over and over, but you remember nonsense.
Yeah, and now, Go ahead, sorry.
How does it happen?
Marcel Proust describes in his, for him, for instance, remembering, I mean, he eats this piece of madeleine and dips the madeleine in his teapot, linden tea, and that is serendipitous. And in that case, it brought back his whole childhood. Now, what you allude also to, I mean, we call it nonsense, but it certainly was triggered by some sensory input, that we are maybe not aware of. But what then happens, and that I did not have time, and I have to make it short because I can see another question. What our brain, from physics, we know that these networks, they function like an attractor, right? So a network, I mean, I'm sorry, this was now my, so the networks function like an attractor. And, if my ideas revolve around a particular subject all the time, then, I strengthen these synapses and I cannot get out of this attractor network. So that is, for instance, when, traumatized people, that may happen to them. And there, I mean, I can talk about this subject for ages, but in essence, it can happen that we get trapped in such a network. And personally, I know what I would do when I get trapped, but maybe I answer another question first, and then we can get back to you. But we understand these processes fairly well. And if I have to give you maybe a very simple answer. When I was young, I was not very enthusiastic about behavioral, treatments in psychiatry, but now I am. I do think if you exert another behavior. Let's say I am unhappy for whatever. I'm in love, I'm unhappy. This guy does not show up at the rendezvous. And it does help me putting myself in another context and in another frame of mind by simply thinking about something else. I can force myself into another behavior, and this behavior will get me out of this state.
Mm-hmm. Well, okay. Thank you very much,
and
Professor.
That's how one, yeah, okay. So
Professor
I think Mr.
Mainzer has Violeta, I'd like to ask you to lead on, because otherwise I will have too many questions in between.
Oh, no.
Okay.
It's very good. I can imagine very good communication with between you and Hannah, because you are both in this domain. Anyway, if I see here one hand, and this number one, I don't know who is
Mainzer, yes.
Mr. Mainzer is.
Oh, wonderful. Please, Klaus.
Yeah. Thank you very much for this really exciting and inspiring talk. I have a question concerning Marcel Proust, because the concept of time of Proust. You know, of course, that Proust's ideas of time are very closely to a very famous French philosopher in that time, contemporary of Marcel Proust, and that was Henri Bergson.
Yes.
And Henri Bergson tried to explain the subjectivity of time experiences.
Right.
What we all know, painful minutes seem to be an eternity, and happy hours seem to be only minutes.
Right.
And then he related it to coming up physical theory in that time, and that was Einstein's relativistic philosophy. And he even tried to make a relation between both. And Einstein was not very happy about that, because concerning Bergson, it depends on, as Einstein argued, as a subjectivity of experience, the relativity of time. But in his case, it also depends on the context, namely the context of a physical reference system and its velocity. Then the time measurement are objectively changing according to relativistic theory, but there is a difference. And so my question is, in the beginning of your talk, you mentioned the connection of context and content.
Right.
And now, and you explained the neuronal background and basis of this connection. So my question to the point is concerning our time experiences, the problem of Bergson. How can that be explained from a modern point of view of brain research and cognitive science?
We cannot, I can tell you what we know, and I would not know how to bring that together. So first of all, I did not have time to explain that well, what our brain does. So when the animal runs, let's say 10, or not the animal, when we go 10 meters, our brain codes, now somehow I don't see, now I do see you, Mr. Mainzer. I like to see the face to whom I speak, so I do see you. So, so what happens is the constancy of space is given by the fact that the neurons fire faster and faster, the faster the animal runs. So that my brain, or the animal's brain, can code 10 meters as 10 meters independently whether my parcours is fast or not. Okay, so there the brain keeps or has a metric has a metric for time. So all these cells, not the grid cells, the place cells, they fire, so that all the cells that code for space, they fire, or the firing rate is directly proportional with the running speed of the animal. Okay, so that's how, you know, you have a particular constancy of space, or let's put it that way. Now, as I told you, in the brain during sleep, but this does not happen only during sleep, it also happens during wakefulness when the animal stands still. So after shorter periods, that's why it's good for our memories to have a pause, also if we don't sleep, so that this replay can take place. And consolidate that what we have learned during this replay. You know, our brain makes constructs of what is more important to it and less important. Now, in the animal world, we do not have experiments. What we do, we have positive rewards, but I'm not aware of experiments where you actually punish the animal and see whether it tries to get rid of these experiences. So what I do not know, and we do not have enough recordings, we do not have the right setting experimentally that I can answer your question, that allows us so far with what we have to conclude when these episodes are stitched together, you know, how is time conserved then? I do not know. We do not have a way to so far to analyze this in our, so this is again, that's why I said, you know, one leave this to philosophers, one can leave, or at the moment we do not have something where in this animal world that with this experience that we have, where we can give you an answer, or where I could generate an experiment that would answer your question, right? I can just say the space, or, you know, the constancy of space is given to a certain extent, but actually I have to correct myself even in that. We have a paper that just got accepted last week, and even the constancy of space is not given. So let me give you an example. I showed you these very nice grid cells, right? So, but all these recordings were done in an empty room. If I now put in an object, a number of these grid cells will disappear, and the animal will re-anchor it. So it builds a map of the world that is now re-anchored to this new object if the animal is introduced to a new object. So this new interest, this new anchor will change. I mean, for us, we call this a cognitive map. Yeah, this spatial map. We believe that space and time, content and context is united in the hippocampus to this cognitive map. Now, this cognitive map is a constructed map because depending, you know, if you put one object in, the one animal is interested in an odor, the other animal is interested in something else, each animal will construct another cognitive map. So we are equipped with, you know, Bausteine, we are equipped with, you know, with tools to build this map, but this map will be the significance of the different objects is very clear that for each of us, we'll build a different map. Now, how time enters the equation, that I cannot tell you. I mean, our recordings, most recordings are 20 minutes. That's about the time that the animal needs to cover the entire space. I do not know. I do not know. Would you, on now what I told you, do you have a speculation?
Klaus,
Yeah.
asked, yeah.
I know, only a very short answer. I think your first remarks in your talk are hinting to the solution. Namely, you explained the connection of context and content. Yeah. And so the content, for example, there is something like pain. There is something like time and time duration, which can be measured. And then the context is, this is a painful situation or it is a happy situation. And so the connection must be, but that must be explained by you, must be explained by the connection of the brain, the parts in the brain, which are responsible for time and for the emotional situations of pain. For example, the limbic system, that is a speculation of me, the connection, emotions, limbic system, and the parts which are responsible for our reasoning. I do not know. That is a question to you. What are the basis in the neural connection?
We cannot answer that because of the, the techniques have their limitations. So at the moment in the realm of animal, where I have to tell you that in humans, this type of recordings you can do only, they are being done on epileptic patients, for instance, with this cellular and temporal resolution, but they are very scarce. So we can do this in the animal realm, but we can record from two parts of the brain. So we do record sometimes from the amygdala, where we know that emotions are being processed, but we cannot cover that. You have to understand, we obtain a very small glimpse. So to represent an environment, we would have hundreds of cells. And if you record from a mouse on one day, if we are lucky, maybe we get 10, 15 cells. So we cannot cover this complexity of what then is an episodic memory. We really see the tip of the iceberg. And for answering such a question, would need, I don't know, we poke like 6 electrodes in the brain of such an animal, and more is not possible. We do not, no, I cannot answer that question. Yeah.
No, it's a challenge for the future.
Anyway,
it underlines, and that is interesting for our academy and here for our discussion, it underlines the relation of the natural sciences, for example, physics and relativistic time, things like that, and psychology and subjectivity of temporal experience, things like that.
Absolutely, and this is a very nice argument you made. Shows, there are many biologists or people like me working on a brain who actually think that the answer, a complete answer on memory, will rather come from people from physics or mathematics rather than biologists. So we see the limitations. We can offer a number of solutions for certain things, but and it does help, for instance, because, for instance, to say that we provide evidence why we do not remember things how they really were, if the brain skips whole episodes because they are, and this is not a conscious process, this is a process that happens, we do not know how nature does it. Then of course you wonder, what is the significance of testimonies at a trial? So it has implications also in society. It has, but I don't want to.
Hannah, you disappeared. Do you hear us?
No, the image is frozen for me.
Okay.
So Marisa Dalla Chiara, do you want to ask the question?
Yes, I have a question concerning musical memory. You are also a musician, so perhaps you are the right person to give an answer to a question that is perhaps very simple or perhaps very complicated. So the question is the following. Can we recognize some very specific aspects of musical memory? Because what is impressing when we think about memory, and musical memory and other kinds of memories is the following, at least in my opinion. In the case of polyphonic music, memorizing a piece of music implies referring to some very complicated parallel structures. And this is not the case in other kinds of memories. For instance, memorizing a poem or a fragment of Proust, La Recherche, or even memorizing a mathematical theorem, a scientific knowledge. This means referring to a sequence of pieces of information. In the case of music, simple sequences of pieces of information are not sufficient. And I am always very deeply impressed by the memory of some conductors. For instance, Claudio Abbado had a wonderful memory. He never, almost never conducted with a score. And also Daniel Barenboim has an extraordinary memory. What happens in these particular cases? And is there any scientific, neuroscientific description or explanation of these kinds of extraordinary musical memories?
So thank you for the, grazie per la domanda, signora. I cannot answer your question, but of course, I'm very well aware that there were a number of great, conductors, also Celibidache, Aroncourt. I mean, these guys know these scores, but now there you certainly have a selection, but your question touches what you refer now to is, an extraordinary memory. And that you also have in other modalities, and some people just have a better memory than others. And, if they then become conductors, they just have, and, they get better, but they are good already to start with. So we are not all equipped with the same talent. So that is what you refer to is also talent, and it is an extraordinary memory. By the way, there are several books on people who cannot forget, who have an extraordinary memory. Borges wrote, Funes il Memorioso. But this is actually bad, not to forget. So that is another topic. Some forgetting is absolutely important. Now, to come back to your question, we memorize in different modalities. So music, of course, we memorize in the associative areas of the auditory cortex, but somebody like Claudio Abbado, he may have had also a very, very good visual memory. And I do not know. I saw him conduct several times, but I do not know how his memory was otherwise.
What is happening?
Memorizes this music in a visual modality, in an auditory modality, but also in a memory, in a body memory. So we see that also in mice and rats. If they learn to run through a labyrinth, they can learn, I turn twice, right? And then I turn once left. Yeah. So our memory, and if you play the piano or if you play another instrument, you know that you put your hands where they belong. Okay. So when you're learning something by heart, it's the visual memory, the auditory memory that are very important, but then it becomes what we call subcortical. It becomes structures are involved that are where for your body to It's the type, and that is the not episodic memory anymore. It is what we heard at introduction, that is not explicit memory, but implicit memory. So it's a type of memory that you also use when you learn to ride a bike. Okay, so when you play an instrument, it is also this type of memory where you put your hands if you play the piano, and everyone knows who knows a piece by heart that eventually you sit at the piano, you don't even see the score anymore. Yeah, but you put your hand somewhere. Now with a conductor, I do not know how good their visual memory is, the people that you've met, but they certainly are endowed with a good memory to start with. And we are not all born with the same ability. We know that from school, the teachers know it, the one has a better memory than the others. But you can train your memory up to a certain degree. And if your memory is already very good to start with, of course you will make it even better. So Claudia Abbado, very talented, yeah, but he certainly did not store that in a certain modality. He may have had also a visual image. And by the way, Marcel Proust describes that also very, very nicely. So in a second passage that is in another volume, another protagonist, the writer himself, so Proust, Marcel, he also goes to a soiree. And this sonata is being played. That's the very famous scene of the septet. It's a septet. And there the protagonist sees pictures, he sees paintings, the music evokes in him an angel by Bellini, an angel by Mantegna. Okay, so he has this feelings of synesthesia. So it is known that people who have this ability to that one sensory stimulus evokes a response also in another modality. So, you show them the number 4, and this 4 has a taste, or the 4 has a sound, or the 4 has a color. So they have an extraordinary memory. And so again, I'm sure that we're all endowed with differential memory that then can be trained accordingly. And of course, we also see many conductors that use the scores, right? And that do not memorize as well as an Abbado, or, I don't know. And some people probably even have a good memory, but they need it for security. It may also reflect another, Abbado was certainly very certain of himself, and others, for instance, when I play by memory, I sometimes put a score there. It just helps me to know that it's there. Yeah. So it reflects more than just your memory.
Just Claudio Abbado, in an interesting interview, has confessed that he had a kind of a visual and spatial memory. Because when he was studying a new score for him, he used to walk in his garden.
Really?
House in Alghero in Sardinia.
Really?
Used to associate different fragments of the score to different trees in his garden.
So he used this ars memoria. Signora,
the ancient technique.
That's very interesting. So I think
technique.
By the way, Goethe also used that. And one of my professors in psychiatry, Professor Tellenbach, he also used that. He learned poems by heart, and he would walk and associate them. Is it possible for you? Do you know this interview where I could find it? I would be very much interested. Or is it something that has been published?
I will ask Nuria Schönberg, who was a very, she's alive, but Abbado is no more alive. She was a very good friend of Claudia Abbado.
I would be very much interested in this. Very, very much.
Sorry? Yes,
I said I would be very much interested in this.
Yes, I will try to find out this interview.
Thank you very much. Thank you. Thank you.
Thank you.
And of course, you can get my email via Violeta. So, thank you very much.
I shall send her the mail.
Thank you very much.
May I ask you also something? Thank
Yes.
you first very much for your wonderful, fascinating lecture. Are you familiar with Diana Deutsch? She is a music psychologist in America, and she was researching very many years special aspect. She discovered, and she demonstrated also, that if two people listen to the same thing, for example, an interval, and they call the interval big große Terz, so a terce, or a second, big or little second. They have different reaction to these intervals. They call them with this name, it's like a diagnosis of the interval, but in fact, they are totally different. They have totally different feelings for this.
No, I don't know this, and I think that here we go into cultural and individual differences and into expectations. So there is a lot of research, by the way, on music and language. So we know what our brain does. So of course, music is processed in very similar areas where language, where, you know, individual words, but also semantic, and also the phrasing, right? I mean, how you speak. I mean, and there are nice studies showing, if you listen to a choral by Bach, and now you expect a certain chord, right? I mean, we know how Bach should sound. And if you expect a certain chord and this does not come, your brain, you can measure a certain potential that otherwise you don't measure. So there is lots of research that I'm not that familiar with. It's too far away from my field, about, you know, like it is the same thing. If I say a sentence, which is actually a sentence where I ask a question, and if my voice does not show the modulation that it should show, so if I don't go up, then with my voice, that if you listen to me, you're confused. You understand? If I don't have the right, you know, not the right, you know, the right, I don't know what the English word for that would be, you know, the melody of the phrase. So when I speak, a phrase has a melody.
Intonation, maybe.
Pardon?
Prosody.
Intonation.
Prosody.
The prosody, that's the name, exactly. So if the prosody is not if the prosody is not correct, my brain is processing this, you know, has difficulties. So the brain, you know, we have expectation. So if you say, I go to the cinema, and now instead of saying tomorrow, and then my voice would go down, and if I say, I go to the cinema tomorrow, I mean, you would not know. So what does she want to say? Do you know what I'm saying? So, and with music, this is very, very common. I mean, it is, have you been exposed to music? What does music mean to you? You know, how we process music. So that's not my expertise. I'm interested in that. We have at the Max Planck Institute in Leipzig, we have Professor Friederici, who works on this. So I'm sort of familiar with her work. And I think in processing music, our brain, in many aspects, it's not different from vision or from olfaction or from touch, but there is one aspect that is different, since it leaves probably even more space to your subjectivity than something else. I don't know. And so I cannot answer more than what I've said. Yeah. Mm-hmm.
Yeah, I would like also to tell you something. Maurizio Kagel, the famous composer, had a lecture here at the University of Oldenburg, and he said something very interesting. He said that each person has a kind of luggage, and the luggage contains only small moments of pieces he knows. I mean, musical pieces he knows. And he said, when somebody listens to the same piece the second, the third, the fourth time, is waiting only for this moment. He was touched with this moment. There's emotional intensity.
Describes. That's what Marcel Proust described. I mean, Swan has a very, he waits for the petite phrase to occur.
Yeah, wait for one
whole...
accord, for example, sacre for the moment where these rhythms, or in the Romeo and Juliet from Tchaikovsky, only these three accords. So this he gave this example.
But Violeta, that is also not something that is, in my view, I agree with that. I mean, all when we go to concerts, if we know the piece, we're waiting for that. But, you know, a good writer would say exactly the same. The narrative, I mean, we all wait for, you know, when you read the story, you wait for this climax to come. You wait, and if it doesn't come, we are disappointed. And so we actually also believe, or I firmly believe, that our memories are such that we build a narrative in our life, yeah, and this has a sense. So I think we reconstruct our memories so that what I do at the present is more or less justified. And if that does not happen, I am not a healthy person, you understand? If I say that, you know, these decisions 40 years that I took, if they are wrong, you know, how can I live with that? You know, I mean, but now we are getting into other issues which are not my realm, which are not my science. About my science, I can talk as something precisely. I try to put in a bigger context, but it is like that we try to make sense of our life, you know. And of course, there are many people who are sick where this does not succeed. The synthesis, this harmonious synthesis does not, it's not a successful narrative that one can make. And I think one, you know, waiting in music for this particular moment, we also wait. You know, if you look at you know, a skate, or the skate, if you look at a couple dancing, you know, and skating, you also wait for this one pirouette. You also wait, you know, for a climax. You also wait, you know, because we're used to see things in succession. And in a novel, we also wait for that. And I do think that, but this is something that we have learned, that is a cultural, you know, yeah, I would say so. So when I go to Japan, I've been often to Japan, and, you know, the music says nothing to me. And I'm interested, I'm open, but it doesn't move me. I know too little about it. And it's the same thing if I see paintings. I like Japanese art, but, you know, when I go to a museum in the West, I can immediately place this painting. I immediately know, is this from the 14th century or the 17th century? Lots of associations come up. And Marcel Proust describes that actually also very, very well. It's not, our liking does not stem only from we like it. It stems from the fact that our brain has all these associations, and we experience pleasure by forming these associations. It's the cognitive process that is pleasurable, and that is why we enjoy art that is more familiar to us, much more than something that we cannot place, you know. That does not mean that we should not see anything new, but we have to see it often enough and to know enough, you know, to be able to make this large picture even larger. So that's what I wanted to say here. I think we have another question from Athanasia, from Mrs. Athanasia Prinza. Exactly.
Hello, I totally enjoyed the lecture. My question is about olfactory memory. It's known to be very strong, episodic olfactory memory.
Yes.
Is it only because of the emotional engagement and relations and connections? This is one question, and related to this, we apply a lot of olfactory training nowadays. It's standard practice, and it's really long going. It's many weeks, months, and it's based basically to a standard protocol. From what you said today, it would perfectly make sense to engage all cognitive functions and any emotional investment we could, because we are trying to enhance neuroplasticity and we try to base this on whatever olfactory memory is still there. So what are your views?
Yes, I can say something to that. So olfaction has always been considered a lower sense in humans. It goes back to Plato, to Aristotle. So you probably know that of the 5 senses, it was vision and exactly. They were considered the masculine senses because it was considered that they can give you an objective representation of something, which nowadays we know that it's as little objective as in the other senses as well. And for the other senses, the smell, the taste, the touch, one needs to touch. EASA, it was considered more subjective, and they called this the feminine senses. And now, and of course, viewing them less, not leading to the appropriate cognition. Now we know that olfaction is actually a very peculiar sense. So all these 5 senses, you have specialized neurons that project to the hippocampus. That's why also with smell, we associate spaces, right? Marcel Proust describes it. He describes it, the Madeleine is taste, but of course it's much more smell than taste. The taste is not that precise. So coming back to your question, there is something very peculiar about smell. Namely, in all the other 4 senses, we have specialized cells which are sensory neurons, right? You have sensory neurons for the touch, you have sensory neurons in the retina for vision, and of course in the inner ear that is central. So these are pure sensory neurons. And in olfaction, that is not, and also taste on your tongue, these are sensory neurons. And in olfaction, the cells that we have in the nose are special in that they are a mixture between neuron and the sensory neuron. And something else that is very, very special, they project that, so they also project to other cortical areas that are involved in cognition. But there is one projection that goes directly to the limbic system. Mm-hmm. So in German, in the German language, if you don't like somebody, you say, I can't smell you, in the sense, I don't like to smell you. Yeah. Jemanden nicht riechen können, that's the German expression. And that shows that it's a pure emotional reaction. You have this direct projection that goes from your nose to the limbic system and evokes emotion. And I do think, however, we know that in humans, the smell is not strongly developed. So if you just look at the brain area processing smell, it's very small. If you look at the olfactory bulb of a rat, it's much bigger, or of a dog, or so we do know that in the human brain, smell is not one of the major senses. And if you look how much of our brain is involved in vision, that's enormous, or in sound perception. So it is, for us humans, it's these 2 senses which are, but not because they're masculine or feminine, they are the most important senses because much of our brain actually is involved in that. But there is something very, very peculiar about smell, that it evokes these strong emotions because it's also directly connected from the nose directly to the limbic system. Your other question, you had 2 questions. The other thing to get other senses involved, I do think that nowadays they do that in art. There are some artists, we go away a little bit from classical, painting or sculpture in performances where being used. And of course, I can imagine that if you send your child to a Waldorfschule, as we call them in German, they are very much into, performing, teaching, involving more like a whole body experience, and they do eurythmia and they do I don't know what. So, of course, there are other ways that could be, where other modalities could be engaged more. I personally must say I'm very much a smell person and I like smells, but sometimes it's also very annoying. So if I go to the opera or somewhere and sit in a concert room and there is somebody who has tons of perfume next to me, I could just scream. Yeah. So because it distracts my attention from that I really want to, and so I have a good memory for smells actually, and I think it's very enriching, and you know, it's enrichment in one's life, but too much of it I also don't want. So, but we live in a world, you must acknowledge that if you go now, you are surrounded by stimuli all the time, you know, be it in shops where you have all the different visual, all the advertisements. I mean, it's in my view equally bad for your brain, for everything, but that's my personal opinion. And the same is also for smells. I mean, you have sprays. Well, the first thing when I go to a hotel, I tell them that I don't want that they spray my room. I don't want these distractions. Okay. I think Dušan.
Yeah. I think you are completely right. We came much further than just formation of memory, which was the main part of your talk.
Yes, it's lots about recall.
And you know, you also somehow mentioned implicitly false memories, because we have to have, everything has to have a meaning. No,
yes.
has to have the beginning and the end and everything in between. So if we skip one part of time, if we lose this part of time and memory, we somehow build the memory.
Right. I mean, our brain
memory also takes place in hippocampus or not. That's one thing.
Yeah.
The other thing is we also went further, not so much in formation of memory, but retrieval of memory.
Yes.
And all the associations. So I think that parietal cortex is completely neglected in this respect.
So
and,
let me, okay. Yeah.
All these associations are actually starting maybe around the Geschwind part, but I think all parietal cortex is a kind of multi-purpose.
So I did not go into this so much because I don't know, I did not want it to be a talk just for medical people, but so you had like two questions, so to say. The first one was constructing memories, and I mean, our brain fills in, and that the hippocampus does it already, but also the visual cortex. If a picture is not complete, you know, if something is covered by an object, you know, depending how much is covered, our brain completes this picture. Yeah, so we construct, we know exactly, and we call that pattern completion. So that's, and the hippocampus does that, the visual cortex does it, many other brain areas do that. So our brain builds a coherent something from the input that it gets. And that is a top-down mechanism. So you get a sensory stimulus, you have a glass that is covered half, and your brain has seen, you know, we have seen glasses before, and the brain completes this. So yes, that's done in many structures of the brain, on the hippocampus, the parietal cord, in the visual cord, in the auditory cortex. We complete, if certain sounds are missing, we fill in, also in music, we fill in what is missing. That's one point, and that is very nice work showing that. Your other question on recollection, that is such a long topic that I did not want to touch on it. I know the literature very well, and my lab works in part on it. So let me try to make it very simple. The moment I remember something, the memory becomes fragile. So that is very interesting. It becomes labile. So I now put this new memory in a new context, and I need to form new synapses. I need to make new channels. And if I inhibit this protein synthesis, I will lose the memory upon bringing it up. Yeah. Now that is an entry point to therapy for trauma. Okay, because if somebody is afraid of something because he or she has had a bad experience, I bring this memory up, you know, let's put something that's not too drastic. Somebody is afraid of spiders because, I don't know, bad experience. And now you put such a spider in a different context and you let the person experience something where this is not necessarily connected anymore. So you override the memory. You can erase it and can override it by something new. And for that, you need protein synthesis that has been done by an American scientist, Joseph Ledoux, who actually showed in rats, and that has been repeated 100 times, that is bringing up memories, but also from cognitive psychology. There are very nice things that when you bring something up, and now you bring a new stimulus in, during that time, you endanger these memories. So you can actually use techniques to erase memories, right?
Yeah.
Yeah, so I think actually, but that's very, very important, and it is also a mechanism by which we change our memories. Every time we bring them up, and then you had alluded to yet something else, which we do not study in animal work, but that is studied in cognitive psychology. If you bring something up and somebody else makes a suggestion, yeah, you can influence, you know, the memory. We all know that collective memories can be changed, you know, by social influence, by lots of processes. But these are very, how shall I put it? These are processes which, of course, are even more complex. So, but I do think that a number of these individual processes involved in memory formation, memory recall, also happen when we talk about cultural memory, right? I mean, also in cultural memory, there are things that disappear, that are overwritten, but of course, those are other processes. And at the individual level, if I may return, suggestibility is a very strong thing. You know, you just need to suggest to somebody something that makes sense, and he or she might believe it, yeah. And so, but then there are social points that, you know, we try to be liked by others. We try to socialize normally, yeah. We try to be part of a social group. We try to get recognition. So all these processes play a role that in an interaction then with other people, we modify our memories to make them fit in that particular context. Yeah.
Yeah.
Okay.
Yeah. There are no more questions. It's been really very, very interesting. We could talk for hours, I think.
Yeah, but
there's another one.
Yeah, but we make it short because I'm now also getting a bit tired. So yeah.
I'm not sure whether Lisa Malotki wants to ask or it was applauding.
Christina.
I would like to ask something.
Okay.
Thank you so much. So you were talking about transforming traumatic experiences by using different techniques, and you were talking about the confrontation with a dangerous moment. But how would you continue if the person is not able to be confronted with a situation, but needs to work on it, like needs to get rid of the bad memories?
I mean, I'm not the right person now to get into answering these questions. I'm not a psychotherapist, I'm not a psychiatrist, but I know exactly what they do. So, I mean, you can, some people, depending on how traumatic an experience can be, I mean, and even then, but now we are getting into social aspects and individual aspects that are really beyond my knowledge. I mean, we all know that the same trauma can be for somebody so traumatic that that person dies from it, and the same trauma for other people, they are resilient enough to be able to continue to live, right? So in Romania, we had these orphanages. I mean, there were kids who became delinquents, right? And there were kids who studied. Yeah, so it's not just being taken away from the mother and put into an orphanage. You can say that such an experience is, of course, a terrible experience, But it's not at everyone. It's not every woman who gets raped in the war commits suicide, but there are those who do commit suicide, right? And there are those, but these are complex processes that you cannot answer. I mean, there you go into studies with patients, which is not my realm. Yeah. I mean, I worked in child psychiatry, but I really don't want to answer the question. And I'm also not up to date with the literature. I do know what is helpful. I know what I use if I want to get myself out of a state of mind. But of course, we all know in medicine that there are patients whom you cannot treat, whom you cannot get out of this state. I still believe in behavioral therapy, but I also believe, there are patients nowadays, as you probably know, in psychiatry, they use electroshock again, because they want to it is as if your computer gets hung up. And when I was young, I would have been against it. But now, knowing how the brain functions, first of all, electroshocks are not done the way they were done, decades ago, but what you do is like your computer gets hung up and you pull the plug. And that is what is done with a light electroshock. You get the brain out of such a network where it just goes in loops and loops and loops and cannot get out of there. And that I don't say that I favor this type of therapy, but I do think that there are therapies which without some medical treatment or so, you do not get to that state. You do not get. And the medical treatment can be, in the extreme case, electroshock. That's what I'm trying to say. Okay.
Thank you very much for your answer.
You're welcome. You're welcome. So shall we take one last question from Christina Raducan, but very, very quickly, Christina.
Thank you for this conversation. It was really amazing, and I will leave the dramatic area right now. My question is, sometimes it happens that one hears in his head a particular piece of music all day long, random music that one cannot tie with anything. You can't escape it, no matter what you do. It keeps playing in your head all day long. What type of memory is involved with this experience, and why does it happen?
I think we all have experienced that. I do not find it actually, for me, it's not bad. It's not random. That is what I tried to say before. There must have been some stimulus, exactly the same thing. And this stimulus, just because you hear the music, this stimulus must not have been necessarily an acoustic stimulus. It can be that some other association that you're not even aware of. So what distinguishes us people from animals is the large associational area. So those of you who know how the brain looks like knows that the 5 sensory domains are represented in particular places in the brain. Now, there are animals that can hear better. There are animals that can see better. There are animals that can smell better. There are animals that are better at anything that we humans can do. What makes humans very, very special is that next to these sensory areas, of course, not only the frontal brain, but also that we have these huge associational areas. So next to the visual cortex, I don't even know how many, 20, 25 associational areas. So there, the visual cortex is connected with almost anything else in the brain. So any trigger in another modality can also trigger a visual image. And that's why we connect everything with everything. So when you hear, when this melody comes in your head, it may very well be that, I don't know, that another stimulus that you have associated with this memory, and it does not have to be a conscious process. By the way, in child psychiatry, they always say that at the beginning, when somebody becomes schizophrenic, we can actually follow for quite some time which stimulus leads to these ideas that afterwards we cannot follow anymore. So in adult psychiatry, they see things, they hear, but in children and adolescents, when it begins, they very often, there is a stimulus that, let's say from the street, the patient sits in your office, and then there is a bird or I don't know what singing that you may not perceive because your attention is focused on the patient. But the patient hears it and starts off, on an idea that is, remote from that what you're just discussing. So Virginia Woolf, by the way, has described it very, very well in this one novel, Mrs. Dalloway. There is also a protagonist there, and she herself, actually, you probably know, had these episodes, and she describes it very well, actually, how a stimulus outside then leads to a whole and for me it's not pathological, it's normal, or the stream of consciousness, in James Joyce's Ulysses. It's exactly the same thing. I mean, that's what he does throughout the whole novel. This guy walks in the street and there are lots of things happen, and then sometimes, as I said, our brain, these networks, if you repeat a song in your head at the beginning, it comes back 2 or 3 times, you get into this loop, and then it's getting more difficult to get out. Yeah. By the way, if you want to get out, you can put a CD and listen to something else, and you will probably then get out of it. So you need something else to, to get you out of it. Okay.
Thank you.
You said this should be the last question.
Yes.
I'm sure we could talk for hours. It's a very interesting topic, and you are very good at answering and discussing. But I'd like to ask Violeta, your friend, to close the session.
Thank you so much. And I would like to invite everybody in 2 weeks, we have the last colloquium in this semester with Maria Luisa Dalla Chiara and Costas Demetsos. We shall send you the link for this. Thank you again, and all the best for you.
Okay.
Yeah, thank you very much for the invitation. Okay, and thank you for your interest and the very, very interesting questions, because I do think that you touched on subjects that I did not have in the shortness of time actually to get into it, but they're really all relevant questions that come up if you think about memory and how our brain works. Yeah,
it's wonderful. It
maybe
was
we have a chance to hear you again. Okay.
Thank you very much. Thank you.
Thank you. Bye-bye.
Bye. Bye-bye.